This episode of Untold Stories is sponsored by ParaSwap. You'll hear more about them later on in this episode. What is up, everyone? What is up, my friends? I am Charlie Shrem, your host, and you are listening and watching Untold Stories, where twice a week together, we get to dive deep with some of crypto's most influential leaders, brilliant minds, sharpest tools in the shed, to find out how this movement truly came to be, where we are right now, and where we're going. We're talking about the craziest topics over the past few months, like Bitcoin mining and proof of stake and communities, and how we're in a potential everything bubble, or are we in a multi-coin or multi-layer one world? And today, very special guest, we get to have Dominic Williams, the founder, the CSO, the Chief Science Officer, Chief Scientific Officer. How do you like to say it? Chief Science Officer.
Scientist.
I call myself Chief Visionary, Chief Scientist.
Yeah, I'm President and Chief Scientist, and in truth, I work all the way across the org. But
Of course,
I'm still a very technical person, and I'm deeply involved in technical work to make contributions to the internet computer ecosystem.
I was just going to say, for the Dfinity Foundation, which is the main laboratory for the internet computer, and the internet computer has been not only like a major topic over the last few months with people, but really it's now understood that this metaverse or this internet computer is the future. And furthermore, the internet as we know it today kind of wasn't built for what we're using it for. And we constantly see that with things going down like Facebook, WhatsApp, Instagram all the time, our data being hacked by those who we need to protect it, our medical data being hacked by the hospitals that need to protect us. And Dom, what can I call you, Dom?
Of course.
What you've been teaching me and what I've been learning from my research is that we keep like building the same things on top of each other. And I want to read a quote from you to start off the show, because you are concerned that our industry is going in that same direction. And your quote is, "A lot of these proof of stake networks today that people invest in are really just layer 2 applications of cloud. And we find that pretty disappointing. Blockchain shouldn't be running on Amazon Web Services, where they can steal the validator keys and do all sorts of bad stuff." How is that a problem to that specific, Ethereum virtual machine? But how is it also a problem for our larger community?
Yeah. So you're right. I have bemoaned the fact that many of these proof of stake networks are really layer 2 applications of Amazon Web Services, particularly, but in principle, it could be any sort of big tech, cloud infrastructure. And obviously, I got into this through Bitcoin, same as many people. And in the original Bitcoin white paper, Satoshi described Bitcoin as essentially being one CPU, one vote. Now, we all know that it didn't quite work out as simply as that, because you have things like, mining pools. But essentially, to create Bitcoin blocks, you need hashing machinery, machinery that will allow you to spin the nonce in the Bitcoin block you want to propose, and calculate the hash and see if it has some leading 0 bits. So what that means is that the Bitcoin network is created by people who have hardware dedicated to the task. And this is very, very important. It doesn't rely on Amazon Web Services, doesn't rely on Microsoft, doesn't rely on Google. It relies upon this specialized, dedicated hardware. Now, in a proof of work network like Bitcoin or Ethereum, you can think of nodes or participants being either masters or slaves. And the masters are those who are doing hashing and actually producing the blockchain. And then you have the slaves, which are nodes that just download the chain, make sure that no illegal transactions have been made, but essentially just replicate it. But the masters, of course, if they want to, can rearrange the chain and do things like double spends. But we look at the decentralization of the masters, in this case the mining pools, to make sure that no individual actor has the power to do that. I think today, there are about four Bitcoin mining pools, independent Bitcoin mining pools, that would need to collude in order to, rewrite history. in the Bitcoin network, there are about 3 big mining pools that would need to collude. And these nodes that download the copies of the chain are really just slaves. Now, the practice with Ethereum became one where these slave nodes actually were run on Amazon Web Services. So today, typically people developing dApps are putting a website on Amazon Web Services, and then this on the back end interrogates Ethereum nodes that are run by a service called Infura, which is operated by Consensus Inc. And those Infura nodes are run on Amazon Web Services too. Now, I'm actually worried about that architecture for a number of reasons. I don't like the fact that users have to go through a website that can get hacked, be censored, or otherwise, shut down and influenced. But at least, today, Bitcoin and Ethereum have their chains created by people that have dedicated sovereign hardware, whether that's ASICs in the case of Bitcoin, or rigs set up with specialized graphics cards in the case of Ethereum. But the proof of stake networks of tomorrow, often, don't require specialized hardware, and therefore, if you like, the whole thing runs upon and depends upon typically Amazon Web Services. And these guys could shut them down, of course, but worse, they could even steal the validator keys that enable those nodes running on Amazon to produce blocks and arbitrarily subvert the blockchains. So when we designed the internet computer, and it was an R&D effort that took many, many years, we wanted to create a blockchain that would deliver on the world's computer vision. So naturally, it took a lot of work, and we rethought blockchain from the ground up. We weren't trying to create digital gold like Bitcoin. We were trying to create a general purpose public blockchain capable really of hosting all humanity's systems and services using smart contracts, and driving a blockchain singularity that would see all systems, or the vast majority of systems and services, rebuilt using smart contracts and reimagined in the process. And when we rethought blockchain from the ground up, it was very clear to us that the network should be sovereign, and it shouldn't be a layer 2 application of big tech's cloud. So the internet computer is created by a sovereign network of what we call node machines. Node machines are hardware built to community-defined specification, and the network requires information about these node machines that are made available to it. Okay. So this is a break from earlier practices, and it looks at a decentralization architecture, decentralization hierarchy, which is node provider. That's the person or organization that actually owns and operates the node, the data center that the node is being run from, and the geography that the data center is in, and then the jurisdiction. And it looks at this information to combine these node machines into what are called subnet blockchains in ways that maximize resilience and security, while also driving efficiency by reducing the replication required to reach those levels of resilience and security.
So you have a proof of work that requires dedicated specific machines, and you have which was seen for a while as like the old, and for a while everyone was looking at proof of stake as the new, and developing new consensus algorithms that kind of fork proof of stake, delegated proof of stake, different Byzantine fault tolerances, yada yada yada. And I agree with everything you said as it relates to proof of stake networks, and I'm going to say that they are less permissionless. They are permissioned, because that's probably like a gradient, a scale, like how permissionless or how decentralized are you. But like you said, to stake on any blockchain that does proof of staking, and to be part of that governance, or to even own it, or to transact on it, you need to own some to use it. And that could be, you can be prevented from owning some by the ones that own it already, by the blockchain itself can say you're not allowed. But with proof of work, And there's a reason I'm summarizing all of this was proof of work. Uh, it's fully permissionless because there's specific hardware that you can go and access, and energy is fully decentralized. You can go somewhere in the world, you can create this hardware, you can build, you can do it, and then you can go onto the network and mine Bitcoin, and the other ones too. And you've created like a hybrid. You've created like it's like you're marrying the best of the two. You're taking it's still dedicated hardware that you need, but once you have that hardware and you can get it in a decentralized way, it's then like proof of stake, similar to like a helium type of router or something like that.
Yeah, I think that's a fair description. You know, the the internet computer has a very singular purpose, and that's to drive a blockchain singularity. So we needed to create a public blockchain that could run at web speed, had incredible efficiency, most importantly, could scale without bound,
Yes.
could serve web, so you didn't have to rely on websites on Amazon Web Services to create dApps. Um, but we wanted to create something that was akin to the kind of network, i.e., Bitcoin, that inspired me to get into this industry and start working on the underlying theory. So yeah, the internet computer has this sovereign network, and it adds capacity by creating these subnet blockchains, and it tries to minimize replication because, as you know, we want to
Yeah.
host the world's systems and services, so it has to run efficiently. So we use this thing we call deterministic decentralization, in which nodes are combined that are independent according to this decentralization hierarchy, which is a node provider, either person operating, owning and operating the node, data center, geography, and jurisdiction. And it's obvious to see why we do that. I mean, if you created a subnet blockchain and the same person owned all the nodes, well, that wouldn't be secure
Yes.
because the
What's the point
person
of
could
being
go
here?
offline. Yeah. Now, even if all the nodes in the subnet blockchain were owned and operated by different node providers, if all the nodes are in the same data center, that wouldn't work either. That reduces to the same problem these proof of stake networks have, where they're running on Amazon Web Services. The owner of the data center would have control. So we have to decentralize relative to the data center. Now, there's further levels of decentralization that are also necessary. So it's possible for disasters to befall local areas. I mean, God forbid, but a nuclear bomb could go off. So
Sure.
we
Yeah.
want to make sure that data centers are dispersed across a wide geography. So that's why we decentralize according to that too. And finally, geography isn't enough because you might use data centers all across Europe, but they'd all be in the EU, the
Sure.
European Union. And if the European Union banned blockchain, then you'd have another problem. So um, the internet computer creates these subnet blockchains to increase capacity by combining nodes that are independent according to this decentralization hierarchy of node provider, data center, geography, and jurisdiction. And that allows us to um, create the required level of resilience and security at a much lower level of replication, with the cost, of course, that the participants have to reveal information about themselves. And that's a trade off, but it's a trade off we're happy to make in this particular case because we have to drive towards these levels of efficiency if we want to be able to support, for example, social fi,
Yeah.
social
Of course.
networks that run entirely from the blockchain, where the user's the owner, the user's the team, and where social functionality is blended with DeFi functionality and things like that. So,
Yeah.
it's a trade-off we have to accept.
So that's what we don't realize. It's like if we want to be able to here like Pokemon Go, here you have millions of people utilizing in real time GPS, constantly all over each other. We have to utilize, AR technology. You have to utilize the camera, everything in real time communicating with each other. The internet as we know it today wasn't built for that, but we shouldn't be building the future internet. So furthermore, instead of what you're saying is instead of having, you could have more decentralized services. You can have that type of same situation built in with NFTs. You can have decentralized finance built into it. You can have all of these things, but if we're doing it where it's run on centralized services, then we're not really building a new internet. We're just rebuilding. The emperor has the new clothes or whatever. It's like rebuilding the same thing.
Yeah,
I
I
really
actually
love
find
that.
it in. Yeah, no, I find it upsetting because I find it almost like a fraud. I mean, if you got into blockchain because you believed in the vision of a sort of unstoppable sovereign platform, um, where you could build free of the um, control of some intermediary, if you like, then you certainly don't want to have that intermediary being Amazon Web Services. Look, you may or may not support the policies of Donald Trump, but you might, however, in either case, not be too pleased that Amazon Web Services shut down Parler. Now, if Amazon
Good
Web
point.
Services can shut down Parler, they can certainly shut down a blockchain. And I think it's great folly that these proof of stake networks are building.
Look how easy it would be. There would be no warning, too. You'd wake up in the morning and you'd see some press article with some news, whether it be real or fake, and then Amazon Web Services suspending like a whole blockchain with tens of thousands of token holders, and that would be kind of crazy.
It would, and it could, it could even be worse than that. I mean, that's probably the most likely scenario. But another scenario is that an Amazon Web Services employee actually gains access to the instances running these proof of stake blockchain validator nodes and steals their validator keys. And once you've done that, you can arbitrarily corrupt the blockchain.
I've invested in and worked for so many projects and companies over the years that have tried to rebuild the decentralized internet through different scopes, like looking at decentralized file storage, decentralized music videos, decentralized metaverse, decentralized of everything, right? And it always comes down to my same question, and then I follow the technology, and what ends up happening, it's like you look at milk, how milk has the fat on the top. And I almost look at it what's the point of putting the metadata of decentralized file storage on a decentralized blockchain if the data itself is still in a centralized place, right? You've been down this road. Oh man, I'm pulling up research here. You worked on in the late 90s something called smart drives. You were working on trying to some crazy stuff, trying pre-Dropbox, pre-decentralized file storage. Why was it so hard then? Why is it so hard now? And do you agree with me that that's what we need to have?
Yeah, look, so I mean, I've obviously been working away at this kind of stuff for a very long time.
Yeah, you've been around the block.
Yeah. So, yeah, you've got some good information there, Charlie. No, it's true. During .com, I was trying to create I think it was probably the world's first cloud service. It was called Smart Drives. And
you probably got laughed out of the room, too.
Yeah, well, people thought I was crazy, and but we got quite far. We got kind of wrecked by the .com crash. It had this system called adaptive redundant transfer reduction, and essentially it was doing differential compression. So when you uploaded a file to the cloud, it would, behind the scenes, it'd be creating a patch against data that was already in the cloud, and we could get these incredible amounts of compression. Much greater than you could do with just, it's like a gzip algorithm. And, that was important back then, of course, because we were still using, modems and, mobile data was GPS and so on. So, that came a crop. I mean, funnily enough, I'm talking about blockchain, the link to blockchain. It also had its own kind of certificate system built in, which I sort of cooked up myself in naivety, using things like Diffie-Hellman.
Oh, like a timestamp type thing?
Well, no, it's like ASCII-based certificates and things like that for security. But I was using a library by a guy called Wei Dai. It's called Crypto++. Yeah, and he was one of the pioneers of blockchain. And I remember coming across his proposal for a thing called B-Money in 1999, and I could not make head or tail of it. How I wish I had listened to him more carefully, but I was using his cryptography library back then. In the end, actually, with that, we had this deal with a company called Energous, which was a power company that was running fiber optic cables along its power lines to create this
cool.
Yeah, and then they were providing the connectivity to another company called FreeServe, which was at the time the world's biggest ISP. Because what it did is it gave away free dial-up internet access and monetized the telephone lines. So when you were dialing in, a little bit of the money was going to the telecom company, and a little bit of the money was going to FreeServe. Anyways, I was working with Energous, and the plan was to sort of create this cloud service through FreeSurf because there wasn't any cloud, there wasn't any infrastructure I could use to build this thing. So I had to work with partners. Anyway, the dot-com crash happened and kiboshed that because Energous went into administration overnight. It was horrible. But so I've been working, in the field of distributed computing and playing around with cryptography for many more years than I care to recount. And naturally, Bitcoin was very inspiring to me, and that's that's where I got into this. And I guess, look, at this point, I started coding when I was very young. I've been coding for 40 years, and um, I was very into Bitcoin, and I was already working on, the underlying math and seeing and investigating ways to speed up, blockchains. But I got involved with the Ethereum project at quite an early stage, and I came across this concept for a world computer, and it just hit me between the eyes, like a world computer, of course. And I'd seen how the things had unfolded with the internet in the 1990s. And originally there was America Online, CompuServe, Prodigy, and then Microsoft proposed this awful thing called the information superhighway. And thank God we got the public internet, a decentralized global network. And that's why we got all this innovation and creativity and economic growth and entrepreneurial activity, because the internet is permissionless. So, look, if Charlie, you went and created like an early profitable dating site, and I created a profitable dating site, and we were competitors, I couldn't phone up the owner of the internet and say, hey, if you slow down Charlie's website, I'll give you some stock in my company, right? It was a free market. And that's why the internet created all this crazy growth and creativity and social freedoms and everything else. So over time, of course, we saw that wasn't enough. The internet connects everybody and everything, but people are building systems on platforms like Amazon Web Services, but also things like Facebook have become the platform and Google have become the platform, and they, crawl and monopolize user data and network effects. So, things went backward a bit, but, Bitcoin's the next internet. It's going to be the final piece that decentralizes not just the network, but the actual way we build and run things. So when I heard this idea, heard this concept of a world computer, I was like, what? This has to be built. So immediately at that point I abandoned a project I'd been working on called Pebble, which was just a faster blockchain, which had some very some particular applications that related to my own interests at the time. And I started thinking about how we could build fast and, most importantly, scalable general purpose blockchains. And there was another piece to it, okay, which was that I looked at smart contracts. So, I hadn't been coding 40 years then, but, I'd been coding for a long time. And I'd coded every, kind of system imaginable. And I'm looking at smart contracts, and, they were conceived very simply just to be things that would enable you to create altcoins and things like that. But I realized that actually smart contracts were something very, very profound. They were a new kind of software, and not new in the way that uh, um, garbage collected language like Java is new compared to compiled C++. Not new in that way. Something much more profound. So I realized, of course, firstly that smart contracts ran on a public network, which is naturally important. The internet beat out AOL, CompuServe, Prodigy, and information superhighway easily, and blockchain is going to beat out, today's traditional IT infrastructure over time. So they run on a public network, but there's other things about them. Okay, they're tamper-proof. They always run the expected code against the expected data. So you don't need a firewall to protect smart contracts any more than you need a firewall to protect Bitcoin. So that was amazing. They're unstoppable like the internet. Then I saw that smart contracts are both software and systems at the same time. So, when you build software, you build it from components. You write a bit of new code, but you sort of build it from pre-existing libraries, okay? You build it from components. But with smart contracts, they're software and systems at the same time. So now you could do the same with systems. You could build systems from components. And every smart contract can plug into every other smart contract, so they can be part of multiple systems at once. And I realized this was immensely powerful and would create incredible network effects. And I think this is one of the primary reasons why DeFi has exploded on Ethereum. And then finally, of course, you can make them autonomous, and you can apply token with that. You can apply tokenization, which can be used to create microeconomies, viral growth flywheels, all decentralized value, all kinds of things. So, my thinking was, back in sort of 2015, by then, early 2015, I started changing direction. It's like, okay, we've got to create a world computer which removes the limitations from smart contracts. We need smart contracts that can, run at web speed with great efficiency in a single unified environment, which is infinitely scalable. And later on, I saw that smart contracts also needed to be able to serve interactive web content directly to users, because otherwise you've always got an intermediary. The, the smart contracts need to be able to interact directly with the end users of their services. And I hoped originally that this would be Ethereum 2.0, but it became apparent that the amount of R&D work involved, it was just too ambitious. It was going to take too long. So eventually, it became its own project, and obviously, it took many years, and we ended up having to hire an awful lot of the world's leading and most famous cryptographers, for example, to actually create some of the novel cryptography required to realize that vision. But that's what drove us. But the aim was always to create a new internet, something that's sovereign, and that's why the internet computer runs on this sovereign hardware.
You said that your goal is this like blockchain singularity. What does that mean?
So this is absolutely going to happen. If you look at the history of the internet and the reasons why it succeeded compared to the walled gardens that were being proposed at the time, it's absolutely plain to me that blockchain, firstly, is the next internet, and that the because smart contracts are this new form of software with absolutely profound advantages. Even if you're not even wanting to build a tokenized social fi service, even if you're just wanting to, rebuild your enterprise systems, well, smart contracts are going to be a much better choice because they're tamper-proof. You don't need to protect them with firewalls, which fail. So, um, you know, when you see the advantages of smart contracts and you really understand um, what they are, it becomes very obvious why it's inevitable that eventually the vast majority of humanity's systems and services will be rebuilt using smart contracts, but they'll also be reimagined because smart contracts um, provide new capabilities. That's why DeFi on Ethereum looks very, very different to traditional finance. And look, Amazon Web Services is far cheaper than Ethereum. I mean, the cost of a gigabyte of smart contract data on Ethereum is absolutely colossal. It's hundreds of millions of dollars at the moment. Every transaction costs you $50
Yeah.
or something, and yet DeFi exists on Ethereum and not on Amazon Web Services. That's because you can only create DeFi using smart contracts.
Is it also because even though it's more expensive, you know that that smart contract is open source, publicly verifiable at well, most of them at the same time, that Ethereum that you're holding, that you're transferring, that you're spending money to transfer is yours. And at least to for someone for the whole network of Ethereum to ruin its integrity, to freeze just your transaction is probably not going to happen right now at least in the mechanisms that we have. So therefore, that's why even it costs so much more to do something on Ethereum. We're still doing it because the internet, as we know it today, is so terrible, and we're not. It wasn't meant to do what we meant. But I didn't know what is this Microsoft Information Superhighway that you were alluding to. What it was a walled garden that was proposed in instead of what we have now.
I could have got my history wrong, but as I recall, they were pushing this thing to governments. I think there was some critical juncture um, when the internet was really growing and taking off, and consumer adoption was accelerating. Where there were various corporations suggesting different ways of doing things and proposing that they could create um, walled gardens where all the content would be carefully curated and
Yeah.
all the users would be much safer. But I mean, please don't take the history from that. I mean, I haven't checked the facts for a long time, but generally speaking, there were competing views in the late '90s about what the internet should be, and on the one hand, there were people saying that it should be a kind of walled garden with corporations curating the content and so on, and on the other hand, um, there was just this sort of beautiful decentralized protocol which enabled any ISP to extend the open public internet and anybody to connect to it and provide services. And, it was this latter approach that easily
So
won out.
cool.
And I think the same is going to happen with blockchain. Look, I mean, if you're a developer today and you're wanting to, start building cool things that lots of people use, you'd be crazy to do it on Amazon Web Services. Build it in a sovereign environment, build it on the internet of tomorrow, build it on blockchain, whether that's the internet computer or another one. But I will say though that, as you say, Charlie, a lot of the magic is that, the blockchain is this sort of sovereign public environment, much like the internet's this sovereign public network. And, if you build on a proof of stake network that's running almost entirely on Amazon Web Services, I'm not sure, how sovereign it truly is. It's really just a layer two application of big tech's
Well,
cloud. So,
especially because we talk about sovereignty, and the reason that's important here is because this was never proposed in the early internets or even until 2009. But we have something called governance now. It's now a two-way street. It's now the users and the abusers. No, the users and the holders and the miners and the node runners. Everyone can participate. Not can participate, but has a uh um the ability to participate in governance and to, we just saw with Polkadot the other day, there was a big parachain type of vote, and there was a lot of, you do all this tech and R&D work, and then you risk that your holders won't actually approve it, or that they will, and it keeps the integrity of the system. We never had this governance thing. We never had it before. So we don't know how it gets involved in the social economics of everything. Do we want to participate in governance? Some people don't want to be their own banks. I want to hold money and let someone else vote for me. It's a lot of work. So you've kind of looked at this, and you've developed this node nervous system that kind of governs the internet computer. What is that, and why is that so novel?
well, standing back, of course, the internet is a public decentralized network. But actually, there are some centralized organizations that
True
play a
story.
very major part in operating it. So most obviously, there's ICANN, and you could joke around and say, when Vince Cerf and the others, ran ICANN, they also created an illegal securities ledger of things called domain names. And these things became highly speculative digital assets, and everybody
Yeah.
was trading these domain names. But um, more seriously, this organization called ICANN plays a central role in the operation of the internet. So, um, blockchain, moved past that. I mean, Bitcoin most obviously didn't rely on the Bitcoin Foundation, say, for the for updates and so on.
Yeah.
The challenge though is that Bitcoin by design, and it's a you know part of its value is very simple. It's producing digital gold, really. Um, but when you sort of push into the realms of general purpose blockchains, the science gets more complicated, and the
Mm.
software that you run on the nodes gets much more complicated too. So um, you want to, and people building on top want constant improvement. So first of all, you need ways of evolving the blockchain that are better than the sort of traditional way of doing things, which is through hard forks. So for those
Yeah.
listeners that aren't so familiar, traditionally with the blockchain, all the nodes are running compatible software, and then somebody proposes changing the logic, changing the protocol, typically in ways that would break the network, and you have to sort of orchestrate a sort of simultaneous upgrade, if you like. And there are ways you can fudge it with soft forks and hard forks and so on. But essentially, you have to get everybody to upgrade. So, key players there's a lot of discussion, and then
Yeah,
key
there's a lot of
players in
work.
the
No turnout. Like even that Polkadot one I just talked about, I got approved, but the turnout was 4% of all the token holders.
oh dear.
And they set the threshold at 2%, knowing that it was probably so. I mean, it's so early and experimental. We don't know how governance is going to be. It's crazy to think about governance like it's just Oh my God.
It's difficult. So you know the problems. And also sometimes hard forks go terribly wrong because they become very divisive and you get two different camps. And some of the blockchain forks perhaps resulted from those kind of differing opinions.
Yeah.
So, I you know, internet computer is very blockchain forward. If it's future tech. We push as hard as we can to solve every problem. And so we decided that the internet computer blockchain would actually run under the control of a permissionless governance system called the network nervous system. And this would run within the protocols. And that would enable the network nervous system to update the protocol and the software running on the nodes, configure economic parameters,
Oh,
and
wow.
also network parameters, because as you know, the internet computer is constantly forming new subnet blockchains to add capacity. So um, we designed this thing, and essentially it works uh, by reacting to the voting activity of things we call neurons. And these voting neurons can be created by anybody. You just have to stake some ICP, which is a sort of governance utility token, inside the network nervous system. And when you do that, you have to specify um, what's known as a dissolve delay, how quickly you can get the staked ICP back
Yeah.
once you start dissolving this neuron, right? So it's a bit like a savings account where you have to give notice of withdrawals. And the longer the notice period, the greater your the greater your voting power, and the greater the voting rewards you receive for voting. And the reason for that, of course, is that you know we expect that people will always vote to maximize the value of the staked ICP on the time horizon um, of when you can first
Yeah.
get them back. So if you've locked up your ICP for 4 years, say, the maximum's 8 years. If you locked it up for 4 years, well, you're going to, at the minimum, vote for proposals that will tend to maximize the value of the staked ICP in 4 years' time. So that's a proxy, of course, a crypto economic proxy for the success of the network. Now, if you do this, you create a voting neuron. You don't have to vote on every proposal manually yourself. And that would actually be difficult because it's already processed some thousands of proposals. What you can do is configure your neuron to follow other neurons with areas of who, for example,
Sure.
belong to parties that have specific expertise. And you can say, like, for example, on a cryptography topic, I'm going to follow these neurons held by 5 cryptographers, and if 3 of them vote to adopt this proposal, I'm going to vote automatically to
You
do
can
2.
set parameters.
Yeah, you can totally configure it. So it's a kind of advanced form of algorithmic liquid democracy. And what's so cool is that anybody can submit these proposals to the network nervous system,
Love
and it
this.
always either adopts them or rejects them. And if they're adopted, it executes them entirely automatically. The only exception to that is a motion proposal, which is designed to align the community,
Sure.
which doesn't result in any execution. It's just there for people to either adopt it or reject it. Um, but all the others, you put them in, and if they're adopted, then they're executed immediately, and that could be creating a new subnet, it could be installing new software on the nodes. So obviously it has to be very secure. Now currently,
That solves
it's
the biggest problem with politics that we have today is like that relationship between your like immediate representative and you. There's no direct relationship of like constant stream of information and communication.
It does. There's still some work to do. I mean, what happened was, so there's a couple of organizations in the space. One is the Definity Foundation, which we all know about. Another one's called the Internet Computer Association, which is still very nascent, and they run neurons. Um, these neurons actually aren't controlled by the organizations. These neurons, in turn, for the purposes of security, actually just follow a whole bunch of engineers and cryptographers and so on. So what we did is when we created this thing called the Network Nervous System Front-End DApp, you can find it at nns.ic0.app. It's actually served straight from the blockchain. Is we provided these neurons as suggestions when people created their own neurons, like, hey, if you want to follow some neurons, you can follow these kind of
Oh,
thing.
very cool.
Yeah, no, it was great, but it was too convenient. So of course the result was everybody just followed the foundation neuron and the ICA neuron, which in turn, by the way, aren't controlled by the foundation or the ICA. We've thrown away the private keys. They're actually controlled by their followees. for security reasons. But so you're not really just following one organization, you're actually following lots and lots of different engineers. But nonetheless, we don't like that. So we've begun working with the community, and we want to see lots of people creating neurons and publicizing their neuron identifier so that other people can follow them. So that's something we're working on at the moment. That's going pretty well. So in the long run, we want to see, we don't want to see, everybody just following the Definity Foundation's say, even if in practice that neuron isn't controlled by anyone, the private key was thrown away, it just follows other people. We want to see people following, a broad range of community members. And, it doesn't matter if the people work for Definity or work in a university, or they're just, community members interested in general governance. But we want to see lots and lots of people creating neurons and advertising the addresses. And we've been sort of looking at, and we haven't got there yet, but we've been looking at, how we can tweak the tokenomics to encourage people to do that.
Sorry to interrupt your regularly scheduled programming, but I wanted to tell you guys that if you're using PancakeSwap, Uniswap, DYDX, SushiSwap, you're doing it wrong. You need to be using ParaSwap, because ParaSwap is a user interface, a decentralized smart contract platform that sits on top of all of these. And when you go to ParaSwap or untoldstories.link/ParaSwap, because they're refunding your gas, if you go there, then you'll be able to, on top of Ethereum, Binance Smart Chain, and Polygon, look for the best prices for your tokens and swap and do everything in one predefined transaction on chain. Instead of having to do the approval to this token, to that token, to do all these different things, ParaSwap does it all for you. It's decentralized. They just released their API version 5 that you can see everything. It's all open source. Very cool stuff. untoldstories.link/ParaSwap. If you're using any of the other decentralized protocols, you're doing it wrong, because you need to be using the routing, beautiful ParaSwap routing system, and it's fully decentralized too. It's gorgeous. I'll talk to you guys soon. I wanted to ask you if you are hiring and if you are looking for specific types of entrepreneurs and businesses to launch things on top of the internet computer to come work for you.
Yeah, it's a really good question. So look, I mean, it's very important. All sort of organizations trying to change the world in the way we are, own their strengths and weaknesses. And, I think it's true that firstly, when I was first involved in blockchain, it was a field for enthusiasts, people who are passionate about the technology and the changes it could bring about. So, I count myself as a sort of blockchain maximalist, on a mission to create a blockchain singularity. And so, we back in 2017, and we've been working on it for a while, we raised money and went into the sort of proverbial garage and set about producing what we hope could deliver realize the world computer vision. And, obviously it was a bit bigger than a garage. In order to do this, we had to, create research centers around the world. And, I'm talking to you from Zurich, but we have other centers in San Francisco and Palo Alto, and these remote teams all over the place. And, we had to build this R&D organization, and that involved obviously hiring a lot of talent. And it's no secret, I think we probably have more of the world's leading cryptographers in one organization than any other organization in tech. So, we built this thing out. We've also got other kind of leading lights from different fields, like Andreas Rosberg is the co-inventor of WebAssembly. He joined in 2017. So, we built this organization out. We hired a lot of talent. Actually, organization building is really, really tough, as I found out.
Yeah, it is.
Really, really tough, especially in fields like crypto, where everyone's a little bit, anarchic and decentralized anyway. So, it took a long time, to get all of that talent working together really effectively. It's not just even about the talent alone. So we did that, and truth be told, we created an absolutely extraordinary R&D organization, and we pulled off some amazing feats that exceeded, my best hopes by a long way. But we went live with Genesis, and we sort of stumbled, or I did, out into the limelight, and doing our best with marketing and PR and so on. But I think I sort of imagined everyone in blockchain would be, hooray, you've solved these fundamental computer science and blockchain problems. This is fantastic. We're moving the game forward. Of course, the reality was, in those years when we'd been in the garage, blockchain had become this sort of $1 trillion industry. And there's all kinds of competitors with hundreds of billions of dollars of tokens at stake who certainly didn't like us. So it was a very tough baptism of fire we faced. We faced market manipulation, news blackouts, shilling on social media, lawsuits. I mean, you couldn't make it up. It was incredible. And we also had some craziness inside. So we survived all of that, and the great news is
Here
that
you are today.
just here I am, and the adoption's going really well. So, engineers are a pretty smart bunch, and there's, a sufficient number of them. We've got hundreds and hundreds of people building now on the internet computer, and what is it, five months in? So that's going well despite everything. However, what we are looking for is sort of shrewd blockchain business people who know how to deal with this environment, and have the kind of smarts, because blockchain is an industry completely unlike any other.
Yeah.
It still remains fairly unregulated. It's a wild west. There's a huge amount of money at stake now. There's a lot of different actors. It's ferociously competitive. And I mean, all kinds of things go on. I won't mention all the things that have happened to us. Yeah. But, that's all good. So, we definitely, we would love to speak to, I mean, people like you, that have sort of perspectives on,
Thank you.
communicating blockchain to the complex blockchain issues to the wider world. I mean, you touched on sovereignty. I think that's not nearly talked about enough. Also, people who can, help navigate and compete in this sort of Byzantine environment that's arisen. So
I want to come work for you now. That sounds exciting.
There you go, man.
Yeah, it sounds great.
Yeah, so that those kind of people, and also I want to talk as well to potential blockchain entrepreneurs about why they should build on the internet computer. So, the community of people building is growing every day, and there's all kinds of interesting things being built that you couldn't even remotely build on another blockchain. I'm gonna give you an example: OpenChat. So OpenChat is going to be SocialFi. It's a chat service. You can find it at oc.app, and it's served directly from the blockchain. So when you type in oc.app, it'll redirect you to some strange-looking address. And this is it looks at the moment a bit like WhatsApp, but it's going to be very profoundly different. So in the future, your chat account's going to be a wallet, and you're going to be able to send crypto assets and chat messages. You're also going to be able to notarize documents on the blockchain, sign documents, organize, negotiate, deals for NFTs and make atomic transfers. Like the chat of tomorrow is going to look completely different to the chat of today. And there's going to be the spectrum where you have like social and games on one end and pure DeFi on the other. And then you're going to get in the middle things like DeFi and SocialFi, and this is going to be huge. So anyway, look, this is an example of a team building. Now, why did they choose to build on the internet computer? Well, firstly, very obviously, it's true Web 3.0, and we'll get back to the importance of that in a moment. You can build something without any reliance on traditional IT. So there's no website on Amazon Web Services. This thing lives on the internet computer. The smart contracts are fast and efficient enough to process chat messages, and they're actually serving the web content directly into the browser, which is done using some clever cryptography, which I won't get into here. So first of all, it's the only place you can do something like that, but there's much more. So, one of the things I've been coming across recently is, people come to me and they say, teams come and they say, hey, we'd love to build on the internet computer, but, your grants program is giving out these relatively, small grants. And it's true, I think we've given out 100 grants so far, but they're pretty small. Meanwhile, this other, big proof of stake blockchain is, the foundation is going to give me $500,000. So what I'd say to people is, believe in decentralization and don't curse yourself by following that route. And I'll explain why. What's coming is something called the service nervous system functionality. And it's going to enable you to take something like OpenChat and decentralize it. So the smart contracts that it runs on actually are assigned to the control of something that looks like the network nervous system, but is actually created for purpose. A turnkey service nervous system, okay? So today, the internet computer network is controlled by the network nervous system and has an accompanying ICP ledger, which is, the ledger of governance tokens that you can use to create neurons. So in the future, if you create a dApp, you're going to be able to fully decentralize it by creating assigning control to a turnkey service nervous system and governance token ledger.
Oh, so
Essentially,
cool.
yeah, that service nervous system is like a super DAO. That's one way of understanding it.
Yeah.
But I'll just run very, very quickly, run through the process that's involved. So, let's say you're open chat. You're ready to decentralize, you press the button. At that point, the network nervous system creates a service nervous system. It's the same technology as the network nervous system, obviously. The service nervous system now controls open chat, right? The developers of open chat have lost control of the smart contracts that it runs on at this point. The service nervous system now creates a governance token ledger, which is again the same technology as the ICP ledger, compatible with exchanges worldwide and so on. It creates 1 billion governance tokens, takes some proportion, say 40%, and auctions them. It uses a single clearing price auction.
Sure.
And people will buy those governance tokens using something called cycles, which is like a stable currency on the internet computer. The service nervous system will hold the proceeds from that auction and return to the participants the governance tokens, let's call them OCT in the case of open chat, in the ratio 90% neurons, 90% ready locked inside the governance system, 10% liquid. Now, the service, the DApp, is running completely under the control of the service nervous system. And you should have thousands of people holding neurons, voting neurons, that enable the service nervous system to make decisions on things like software updates and economic configurations. Once that's happened, and it's fully decentralized and autonomous, the service nervous system then grants back to the original development team some tranche of governance tokens, again in the ratio 90% neurons and 10% liquid. So obviously that tranche is smaller though than the tranche that was auctioned, so it remains decentralized. The key bit though is that now you're running as an extension of the blockchain. You're no longer a DApp, you're running as an extension of the blockchain with your own microeconomy within the blockchain's macroeconomy. And this means you can employ very, very sophisticated tokenization strategies. So for example, with OpenChat, what you'll probably see is that if you're online, you might participate in random airdrops. So, Charlie, let's say you're on OpenChat, OpenChat might just ping you out of the blue occasionally, once every week or so and just say, hey, prove you're not a bot. Do this capture or do some other thing that proves you're not a bot. And if you do that, it'll give you some small amount of governance tokens. So the aim is you've got this last tranche of governance tokens and you give them out to users so that users become the owners of these next generation fully decentralized dApps. And the aim is to make the users both the owners and the team. So the users who are receiving these governance tokens become your advocates that bring other people into the in this case chat service, and of course potentially participate in other kinds of things like moderation. So my prediction is that if as expected, service nervous system functionality launches in 3 months' time, these projects that put their faith in decentralization and blockchain rather than grants from centralized organizations will find themselves raising vastly more money than they would have been able to raise than if they'd have taken grants from these organizations.
Well, yeah, of course. No, I was saying it's. So you go. You finish your thought. I'll remember.
No, I was gonna say that one. If you're a project and you want to create something like that, once you've taken a big grant from a foundation, or you take venture capital, it becomes somewhat harder to take the full decentralization route because, I'll give you an example. If you look at something like Uniswap, these things are designed to be fully decentralized. They've got governance tokens and so on. But unfortunately, in the case of Ethereum, you always adapt. Really is a blockchain application. It's a website that backs onto the blockchain, and the developers' names are on the accounts that run the website, right? So that's why Uniswap recently had to delist 50% of its tokens. So, you don't want anybody looking at a dApp and imagining that you somehow are responsible for it. The advantage of this alternative route where you fully decentralize is that you don't, for example, receive the proceeds from this decentralization auction. They're held in this decentralized autonomous organization, the service nervous system. Okay. And it's the service nervous system, the community of thousands of people that
so it's like a token sale where the money goes directly to a DAO and the founders have no control over it. Even the money going through And then the future token holders are the ones that get to vote on how that money's used. First of all, that's fucking brilliant in and of itself. But what I really love about this, and I don't want to forget this point, and that's why I was interrupting you, is that traditionally it's not just grants. Anyone who wants to work for, build on top of, interact with, own a significant amount, you got to contact the team, the foundation, you got to be involved. And your DApp or your project that you're trying to build on top of that layer one, or your layer two on top of that layer one, you rely that you have to hope forever that your incentives are constantly aligned with all of the other dApps and all the other projects on top of that same layer one, because y'all are voting together and y'all holding the same token and voting together on the same proposals and the same upgrades. We're here. I'm able to create my own like sub chain that all of the applications I need to develop and upgrade and everything, it's like my own central nervous system that exists within your central nervous system. And it's fucking brilliant. But how do the millions of subs, how do they support the main one in a secure way, like preventing from attacks and things like that? That's really like my only question I have left.
Well, so to be clear, there's these things are built on top of the blockchain. So you're not creating a new blockchain. It's not like a model. It's not a model like Polkadot where you have to create your own parachain, because the trouble with that is you dilute the security and it becomes
that's what I was getting at.
Yeah, it becomes very difficult to reason about trust because you have all these different trust zones. So the internet computer is a single trust zone. You're just building with smart contracts, and every smart contract on the internet computer can directly interact with every other smart contract on the internet computer just by calling its functions. So it's a completely seamless environment. The subnet blockchains that add capacity to the internet computer are completely transparent to the smart contracts. In fact, the subnet blockchains, and this is a technical topic, obviously, are able to act as a single blockchain thanks to something called chain key cryptography. And that's
so cool.
One of the key innovations at the sort of heart of the internet computer. And that's how we're integrating with Bitcoin and trying to add smart contracts to Bitcoin. But yeah, when once you fully decentralize, like this, the internet computer, the network nervous system controls the internet computer. It also controls the service nervous systems. And then those service nervous systems obviously are created by developers themselves. They ask the network nervous system to create them, but those service nervous systems are created to manage the dApps and services that the developers have created. But essentially, once you've gone through that full decentralization process, your dApp is really running as an extension of the blockchain. You're not running nodes or anything like that yourself. You're still just writing smart contract code.
Yeah.
But it's running as an extension of the blockchain. Because you don't control it. The service nervous system controls it, and in as much as there's a higher controller of the service nervous system, it's the network nervous system, but it would only ever step in the event there was some disaster. So blockchains, and it's only if you fully decentralize can you employ next generation tokenization strategies, and that's why just pushing for decentralization is so important. And it's the future, because it doesn't just enable you to it changes the very nature of adapt. So today, and we all know, look, I could give you $1 billion and say go and build a competing service to WhatsApp. You wouldn't have a chance. And the reason is that these network effects kick in and everybody's on WhatsApp. Yeah, so if you want to take on WhatsApp, you really have to do something profoundly different. And that's going to involve using, first of all, tokenization to make the user the owner. So everyone wants to be online on a service where they keep randomly get given ownership, little pieces that increase their ownership in the service. But also, use exciting tokenization strategies that enable these kind of services to do things that you can't do with a traditional centralized service.
Well, like you said, the web 3.0 and decentralized internet, I mean, it came out of the internet. It came out of a mailing list. So it's like humanity is constantly evolving itself into the next thing. And, it's so funny because there's so many social networks and chat apps over the years that have tried to do what WhatsApp did. But you're right. It needs to be completely profound, because I think we've all realized that we are going towards this like singularity, this blockchain singularity, and so it's like you're not going to waste time building shit that is on the old, the old rails. I really appreciate you taking the time and really explaining some of these in-depth technical topics to my listeners today, because I really didn't expect to have such a deep understanding of not just how the internet computer works, but how old tech how we're still relying on old tech for some of the other projects and services shit that I've invested in. I got to get on the phone to some of these people after this phone call. Dominic Williams, thank you so much for taking the time and coming on Untold Stories today. Fuck, I really appreciate this. I really appreciate you. Thank you so much.
Thank you so much, Charlie. Glad to be here. And I think it's been a year since we last interacted. And it's good to finally speak. I think we spoke on text messages or something like that last time.
Skype chat rooms back in the day,
something like that.
Early days of Bitcoin. Ago, yeah. All right, I'll talk to you later. Thank you.
All right. Thanks, Charlie.